so let's move on to Module 5. We're going to, once again, there's a little bit of redundancy in this one, and so I'm going to skip through the stuff and focus on the new stuff. So focus on the new topics here. So here's our system class. There are some different methods that are available. We would do system dot. There's also some math methods, and we'll come back to those. So here's our system class. We already saw this with the now, today, and our assertions and our debug. More on that when we get into error handling within, or testing within that module. Here's our user info. We talked about this, so we can access things like the user ID, the associated role ID, the profile ID, what the default currency is set to, locale. In other words, where is this person from? We can use this for multilingual applications. For math, the math class, another thing in our system namespace. There's a bunch of methods, absolute values, minimum, calculate a random number between 0 and 1. So a lot of stuff available. This is just a short list. There are many other things associated with cosine and tangents and all that kind of fun stuff that you did back in your trigonometry classes. Already talked about this. There's the clone. There's also another deep copy version of that. The toString. All right, so something that's that is a new topic here, which is the limits class. Now, the limits class allows you to access the current, or to access the current state of the governor limits within the context of where you're executing. So for instance, in this line of code, what this does here, this limits.getDML statements, this will return the number of DML statements that we've already executed. Keep in mind that for our triggers, this is set to 20, and then for the visual force controllers or custom web services, this would be set to, the maximum would be equal to 100. There are two versions of each of these methods. So the first returns, which is the version without limit in there. So the first returns our current position, our current state. So if we've executed 5 DML statements, get DML statements returns 5. The second version is get limit for whatever it is. The limit is going to return that ceiling number. So the ceiling number is the in the current context. In other words, if our entry point was a trigger or a controller or something else. And also remember that in certain cases we had those multipliers. So remember that, for instance, in our triggers, we would take the number of results that we can get back from a query and multiply it by the size of the input set. So that limit is not necessarily the same thing every single time the code is executed. So keep that in mind. There's a number of different methods available associated with our different governor limits. So this is a subset of all of the available ones. But you can utilize these for debugging purposes, and you can print out some messages, especially when you're running your test code, to dump out messages about when you're processing a large bulk amount of data. Where are you currently, to see that you're coming under the governor limits for the purpose of debugging and testing. Okay. DML and database operations. So we've already done some basic DML operations, and now we're going to get into some more details and considerations associated with writing data to the database. The first is that we have the keywords. You've already seen a few of them, like insert and update and delete. But there are also additional keywords that we can utilize. So things like upsert, which will perform a update if the record already exists, or an insert if it doesn't. There's also things like merge, which we can perform with accounts or contacts. These are associated with the different types of operations that your users might be doing through the web browser. They also have DML equivalents. Okay? Undelete allows us to remove something from the recycle bin and make it an active record. This would often be used with the all rows. Remember that in our SOCL query, the all rows returns records that are not only active, but also the ones in the recycle bin. By the way, there's a field which does not appear on page layouts, but it's called isDeleted. So if you wanted to execute a query where you only got back the records which are in the recycle bin, check to see that isDeleted is equal to true. It's a field, like I said. It appears within your schema browser, but it does not appear on any page layout. Okay, so that's a flag you can check. So undelete, convert delete, there are others. DML statements can take one of two forms. The first is the standard or the standalone keyword. So we would just say delete in this example, and then either a record or a list of records. Then there's the database.delete. So this is a method-based format. And once again, we would pass this either a single S object or a list of S objects, okay? As it says below. Now, I'm going to show you in a bit why there's certain cases where you would want to use the method mechanism, because it gives us some advantages, or it does some additional things. So here's some sample code that just kind of shows performing DML operations, writing to the database. We're creating new accounts. We're then inserting them. Make sure that anytime you insert a new S object, that you set all of the required fields. Okay? Not necessarily true if you're doing an update. If that already has a value for that required field, you don't need to reset it again. If it's in the database, it's in there. You don't need to worry about it. But when you're inserting, make sure that you have all your required fields set up. And then also down here, we have our update on a contact, update on an account. We can reference it using that reference to the remote object. Here we're doing an upsert. I'll talk about exceptions in greater detail, but there's DML exceptions. So one of the things that might occur when we're executing our DML operation is that it might throw a DML exception. The DML exception can be caught either when we are executing the standalone or the method-based version. So don't think that it's just necessarily something that only applies to the method-based version of the DML operation. All right. In addition, before you do that DML operation, one of the things you can set up when you're using that method-based technique is this DML options. What this does is it gives you a little bit of further control over what you're doing. The example I would use is that you can identify when you're operating on accounts, cases, or leads. You can identify whether or not you'd like to actually execute the assignment rules. So you can, if you're performing an insert or something like that, you might want to just be inserting them but not executing the assignment rules. So you have a little bit of flexibility over whether or not you'd like to do things. In addition, the truncation behavior, referring to if we have the value of a field is beyond what we've identified as a part of our field settings. So for instance, a text area, the max size is 255. Well, do we throw an error? Do we throw a DML exception? Or do we simply truncate the first 255 characters and go with that as a success? All right, so some of the considerations and guidelines surrounding DML operations. Well, first of all, the list of objects, of S objects that you pass to a DML operation, at max, it can be 200. So even though a list can contain up to 1,000, when we're performing a DML operation, that limit is 200. In fact, throughout Salesforce, throughout the product, you'll see that there's a cap based on any time we're performing that bulk write of 200. Same thing goes for our web services API. Even if we're going to insert 50,000 records, we break it up into chunks of 200. This comes back into play when we're creating our triggers, because a trigger, remember that a trigger runs in bulk. Well, a trigger by definition then will never receive in trigger.new more than 200 records. Okay? All right. Each DML operation can operate on one type of S object at a time. So, in fact, you can't even add a contact to a list that is of type a list of accounts. So when you're creating that list, it must be of a concrete type. But keep that in mind that you cannot, for instance, in one DML operation, insert both contacts and accounts, or for that matter, any other different types of objects. Once again, the required fields, you need to supply those values. So inserting a record, when you perform that DML operation, so if you have a record of A, so let's say we have our account A, and you insert A, it will automatically set the ID on A. So you do not need to, for instance, perform a SOQL query to get that ID that was created by the database. Remember that IDs are all record IDs in Salesforce are always created by the Salesforce database. Okay, but one of the things that we automatically do is populate that ID field. Let's see here. So the ID for the current S object record cannot be modified, but the related IDs can. In other words, the record that we're associating with the current one, we can change that to point to a different record, something we'd want to do. When we perform an upsert, for the purpose of understanding what might happen when our triggers fire, it breaks it into a separate insert. So if we upsert 200 records, let's say 150 of them are new, we'd have 150 of those be triggering a insert event, and then the other 50 triggering an update event. So it breaks it into two patches. When we perform our deletion, it supports a cascading deletion when we have our master detail relationships. And then the merging, just so you know, it works with 3 records, much like in the GUI. It works on 3 records at a time, and it's limited to leads, contacts, and accounts. There's a reference to this. The S object must have the able attribute set. If we go back, and then here it says, for example, in order to insert the S object must be insertable. Well, that's a small typo, because if we take a look at our schema, so I'd just like to show you that in our schema browser, when we take a look at a S object, there's this access area, and notice that it says creatable, deletable, layoutable, queryable. So all of these are, think of them as actions, if you will, that you can perform associated with this object type. Not all of these support all of these different types of actions. So this is the place to go to see what you can do with different S object types. Now the reason I pointed out that typo was that there actually is no insertable access, it's creatable. So it's one of those things where maybe a couple of developers weren't emailing each other at the time. So it needs to be creatable in order for you to insert it. But updatable, undeletable, and deletable all match up with their DML verbs. There are some objects in which you cannot perform DML operations through your Apex. So for instance, the user, you cannot programmatically define new users through Apex. You need to either go through the tool or the web services API. There's a number of other things like territories, profiles, record types, so on and so forth. Those need to be declaratively created through our tools. All right, let's talk about transactionality of the different operations that we're performing. So let's say that we are inserting 20 records. So we have a list of 20 positions, and we're going to insert those 20 positions. Well, when we're using the standalone command, that is going to treat that DML operation of that list as an all or nothing. In other words, if just one of those records, maybe it doesn't have a required field, the field data is too long, whatever it may be, if one of those records throws a DML exception, fails, all 20 will be rolled back. Okay, so it's an all or nothing proposition when you're using the standalone keyword. Now the advantage of using the database class and the method is that it has a, method is overloaded, and there's an optional second argument that you can set equal to true or false, whereby you can indicate that you want all or nothing to be equal to false. So in that example I gave, if we're inserting 20 records, one fails. If we set that second argument equal to false, 19 will succeed, but only one will fail. Okay. Now, in general, so that's the transaction concept in association with a DML operation. There's also, remember that we had our unit of work in the sense that, maybe we called some code in a controller that then performed a DML operation which fired off a trigger. So there was a concept of a transaction not only in the context of our governor limits, but that also applies to the context of the transaction in terms of committing the data. So anytime that we do something and it fires off a sequence of events in which we are calling triggers, or we might be calling other classes, they're doing different things, all of that is a single transaction based on the first thing that the person did. What we do is, if that succeeds without throwing an uncaught exception, then all of the data will be implicitly committed to the database. So any sort of DML operations will be implicitly committed at the end of that transaction. If we have one uncaught exception, everything that we were doing in terms of writing to the database will be rolled back. Okay? So exception handling is very important in the sense that if you want to possibly handle exceptions, especially DML exceptions, in which case you want to partially operate on the database, you really need to handle those DML exceptions to be able to consume the errors that you receive so that the other parts of your code will successfully complete. Okay. Now, you also have the ability to control that transaction level in the sense that you can create save points, and you could define your own logic for rolling back a section or a subset of the operations that you performed. Okay? Now, one of the things that we can do is we can set up a save point. We can then execute some DML operations, take a look at the results, and then decide whether or not, maybe in an if statement, whether or not we want to roll back all of the things that we did up until back to that save point, or whether we want to just continue processing and do that implicit commit at the end of this transaction. So let me show you some code where one of the things that we're doing is we're utilizing both the save point and then the rollback. So what we're doing here is we are declaring and instantiating a save point at a location within our code. So there is a database.setSavePoint method that we're calling. The next thing that we might want to do is we might want to call, maybe we want to insert some accounts, and then we would want to insert some contacts. And maybe our logic would be something along the lines of, if the insertion of the accounts succeeds, and then the insertion of the contacts fails, we want to roll back inserting our accounts. So maybe we want to combine those into a single unit of work that we might want to roll back in whole. Well, in that case, we perform those two different DML operations associated with our two different S-object types. Then take a look at our results. Maybe we're setting some flags or doing something along those lines. And then in that case, if one of them failed, then we want to roll back everything. What we would do is, in declaring this new variable that is our save point and calling that setSavePoint method, later on, after we take a look at the results of our DML operations or any other sort of thing that we're looking at, we would then call the rollback method associated with our database class and pass it the save point variable that we created previously. What it does is it basically behind the scenes, it goes, okay, any DML operations that occurred in between my setSavePoint and the call to the rollback method, do not commit those to the database. Okay? You can also declare up to 5 save points, so you might have more complex logic whereby you can not only go back to the last save point, but you might go back to a previous save point that was declared earlier within your code. One other thing I'd like to point out is that this is not a go-to, so it's not somehow going back to a section within your code. It's simply saying do not commit the data that anywhere within there that I was writing to the database, do not commit that data to the database. All right, I want to very briefly talk about workflow. One of the things that's available, we don't get into great detail here, it's in the documentation, but one of the things that you can do is you can automate the approval process. So in our declarative setup menu, we can create approval processes. Now, in order to kick one of these things off, a user has to go into the UI and click on that Submit for Approval button. Well, we can programmatically submit an approval through Apex, so we do not require that user to click on that button. Same thing goes for actually we can automate the approval process in the sense that we can automate one of those approvals. So there's a few things that go into this. The process submit request is a class. It contains references, for instance, to the record that is being submitted as a part of the approval process. The process request is just the parent class to both the process submit request and the process work item request. And then finally, just to wrap things up, our user-defined classes that we create can be referenced anywhere within our code as long as they're accessible. Oh, user-defined methods passed by reference can be recursive, can be polymorphic. So, all right. Why don't we take a moment to open up the class to any questions about anything that we talked about. All right, yes, David, do you have a question?
Yeah, so if you put a save point in and you just complete the method, does it auto-commit, or do you have to put it explicitly commit, or how does that work?
Great question. So the question was, if you place that save point, and let's say you do not call that rollback, do you need to perform the commit? In Apex, there is no explicit commit. There is only an implicit commit that occurs at the end of the transaction. So there is no method, for instance, something like a database.commit that you can call. It just implicitly occurs at the end of the transaction.
What if you wanted to commit at different places? You can't do that?
No, you can't do that. So there's, at the end of the day, is there a commit method that is available? I can't really, there is no commit method that you could then do that segmented commit logic within your code. So, yes, question?
So I was wondering if you could do workflows through setup, why would you use Apex? Because that was one of the rules, right? Don't use Apex if you don't need to.
Oh, well, no, okay, so the question is why would you want to do our approval processes through Apex as opposed to using the setup menu? Well, I think that the difference here, I probably didn't highlight it enough, but the difference here is when we are operating on approval processes, it's referring to the execution of the approval process as opposed to the definition of the approval process. The approval process would still be defined through the setup menu. What we're doing is we're replicating the user clicking on that Submit for Approval button and submitting a specific record for the approval process. So it's the automating the execution, not the definition. Good question. Any other questions? All right. What I'd like to do then is to do our module review. So does Apex use explicit transactional calls such as commit and rollback? So this one is a trick question since it's 50% true and 50% false. So yes, Apex does use explicit calls for rollback. Apex does not use explicit calls for commit. Okay, there's the implicit commit at the end. The assert family of methods belongs to which class?
The system class.
Very good, the system class. Ray, what do the limit class methods help you manage? Exactly. So it's for our ability to be able to programmatically dump out and view our current context for the governor limits. David, list an Apex process class used for workflow. Well, where workflow is a generic term for things that appear workflow rules and approval processes. So that was the process submit request, referring to our approval processes. We can also do individual workflow items, in other words, steps within our approval processes. All right. Todd, can you tell me one of our math methods?
Math.min.
Math.min, so return the lower of two variables that are passed to that. List 3 fields, you get the hard one here. List 3 fields obtainable from user info. So, Zhang.
Name.
Yeah.
Username.
The username.
ID.
User ID.
Session. ID.
Yep.
Locale.
Locale. Very good. That's 4. So, very good. So there's a lot of stuff. Like I said, two of the key things are the role ID and the profile ID, programmatically determining which role and which profile that this user has been assigned to. You might want to create some conditional logic based on what you get back there. Okay?
For more information on Salesforce.com training and certification, please visit www.salesforce.com/training.